Hi and welcome to this video course on data analysis with Python by Packt Publishing. My name is Marco Bonzanini and I'm a data science consultant. After a few years as a software engineer, I went back to school and I obtained a PhD in information retrieval. So today I specialize in building search applications and text analytics applications. And I've enjoyed working on a variety of data analysis and data science problems. Python is my first choice for most of my work, and I try to be active in the community and to promote the use of Python. In particular, I am one of the co-organizers of the PyData London meetup and conference. So this video is a complete overview of the video course, so you can have a general view on the roadmap for the course. In section 1, we'll start with some Python core concepts. These are the fundamental concepts of Python that can be applied in many data analytics applications. We'll discuss the built-in data types as well as how to access raw data in different formats and how to handle data efficiently. In section 2, we'll introduce the library NumPy, which is short for numeric Python. NumPy is crucial to perform efficient array computation as well as matrix computation. While the library itself doesn't offer a lot of high-level data analytics features, it's probably the most important building block for other higher-level libraries, so understanding how to use NumPy will open the doors for building some custom analytics features. In section 3, we'll introduce Pandas, a very important library for data analysis. Pandas is built on top of NumPy for fast computation, and it allows to work with data in a table-like, or if you prefer, a spreadsheet-like format. It's all in all one of the key tools for performing interesting analytics on our data. Section 4 will put everything together with an exercise using a real dataset about the Titanic disaster. So we'll use this exercise to recap what we learned about pandas and also to introduce some concepts of machine learning and predictive analytics that will be implemented in Python using the library scikit-learn. So this is the overall roadmap for our video course. The purpose of this video course is to get you started with data analytics and data science using Python. One of the main reasons to choose Python is that the language is very easy to learn, so Python users often come from a variety of backgrounds and don't need to be hardcore software engineers to be productive with the language. Despite the focus on data analysis, Python is anyway a general-purpose programming language, so this means you can easily find libraries and tools to build all sorts of applications. Finally, with a focus on data analysis, what makes Python really stand out is the rich and mature ecosystem for data analysis, data science, and machine learning. By the end of this course, you should be able to know how to explore a new dataset to understand its potential. You should be able to carry out some analysis on different types of data. You learn about machine learning and you should be able to design a system for predictive analytics. And in general, you should get an appreciation for the rich Python ecosystem and you learn what are the most important tools for scientific computing. In terms of prerequisites, in order to get the best out of this course, you should be somehow familiar with Python or even with other dynamic languages. For example, R and Julia are also common choices for data analysis. We're not going to discuss much theory, but data science and data analytics are usually about applying concepts of statistics to our data, so having some sort of appreciation for basic math will be useful. This course is not about software engineering, so you don't have to be a hardcore Python developer to follow this course and to enjoy this course. And also, this course is not about using large-scale frameworks for big data analytics. This is about using Python and its libraries efficiently on a single machine. Some general information about our setup first. The course material is tested using Python 3.6, which is the latest Python release at the time of this recording. The code is in general compatible also with Python 3.4 and 3.5. Older versions of Python are not explicitly supported. To make your life easier, the suggestion is to use the Anaconda distribution of Python. Anaconda is a distribution which is tailored for scientific computing. It's provided by Continuum Analytics, so you can download it from their website continuum.io. The key tool of this distribution is called Conda, which is an environment manager and a package manager, and in the next slides I'll give you some tips to set up your Conda environments. The code for this video course should be bundled with the course itself, and it's also available on my GitHub page, so you can download it from the GitHub repository linked at the bottom. The code is shared as a set of Jupyter notebooks. If you haven't used Jupyter before, it's a fantastic tool for interactive analysis, and it's also great for sharing code. The code in a Jupyter notebook is run within your browser, so you can see the output inside the browser itself, and if you want you can iteratively modify the code and see the results. The Jupyter editor also gives you some nice features like syntax highlighting and autocomplete. So to set up the environment, you can download and install Anaconda Python 3.6. Just make sure you're downloading the right version for your operating system. Once Anaconda is installed, from a terminal or a command line, we can use the conda create command, so we can create a virtual environment specific for this project. Creating different conda virtual environments is useful to have multiple versions of different libraries, even multiple versions of Python if you want, on the same system, without getting in conflict with each other. So essentially with different environments, we keep everything clean. The conda create command takes an option --name, followed by the environment name itself. I like to keep a reference of the Python version in my environment names, so for this one in particular it's packed py36, so you can choose what you like anyway. Then we specify that for this environment we're installing Python version 3.6, and finally the option --flag will make sure that we install everything we need without further questions. Once the environment is created, you need to activate the environment, and the procedure is slightly different between Unix on one side and Windows on the other side. After activation, the environment name should be clearly visible in your prompt. At this point, you can install all the libraries you need using the command conda install followed by the library name. To make your life easier, all the library dependencies for this course are listed in a single file, so you don't need to install them one by one. Simply using the conda install command with this conda requirements.txt file will install everything. Finally, you can run the command Jupyter Notebook, and this will open a Jupyter session in your browser. Just make sure that you're running this command from the folder where you have the code for this video course. Before looking at Jupyter, I am also including the command for deactivating your conda environment once you're done with it at the bottom of this slide. So after running Jupyter Notebook, your browser should open to this page. You can see the content of the code repository here. In the folder Notebooks, you have all the code for the different videos. So you can just click on the notebook folder and then you see the list of all the videos. If you click on the notebook for the relevant video, you can then follow along. So now you should be all set and ready to enjoy the rest of the course.